So homework 52 is due tomorrow and we are one day behind the schedule. I was hoping to do the ramp today, but again we wanted to have 100% understanding on a range, trigonometric aspect of range. So I wasn't able to do the ramp problem today. We are one day behind the schedule. So there is the tutorial there. And some of you ask for the tutorial because you wanted to find the velocity of the object that rolling on the ramp. So the velocity is very simple. Vf is equal to Vi plus At. But the A is, in this case, A is of course not 9.8. Why? Because this is not free fall. So A is Vi is 0 because why? Vi is 0 because the ball was at rest and then it started rolling, accelerating. So A is not 9, but as it increases is going to 9, but this is not 9. If it is 30 degree, then this is going to be, so what are we going to use? We're going to use G sine theta. All right, that's what it is. So it depends on the angle. So now what is the equation? The equation is G sine theta, of course, T. All right, that's it. Now let's go over. Let's give you the 100% understanding of this problem. Let's draw it. Let's give an angle. Tomorrow is the exam, so I'm gonna make it real quick. I'm gonna give you this full understanding in less than 5 minutes. All right, so this is 30 degree, and let's say there is a ball, and that is ball is moving to this direction. So there is a friction. Since ball is moving, there is a new case. Let's say this is 0.1. So far, everything you understand. Now, let's derive the formula. If there is a ball, you know that if there is a ball sitting over here, this is Fg, right? But that's not the case, and this is Fn. But that's not the case over there, because this is not on a flat surface. This is not even close to flat. This you can make it, hey, this is close to flat. Not even close. This is close to flat, maybe. But this is not flat. So the gravity has two components. Fg perpendicular, which he has another name, Fn, and Fg parallel, which has something on the opposite direction, because if you move this way, friction try to stop you. Okay, so far so good. This one by definition is mg sine theta, and this one by definition is mg cosine theta. And one day I'll prove that in the class. Tomorrow your exam, so I'm not going to show you the proof now. And then, but if this is and this is at the opposite side of the same thing, then the magnitude has to be the same. Mg sine, mg cosine theta, cosine theta. All right. Ff is of course again mu k Fn. All right. So what is Fn? Fn is this. So Ff is what? Mu k mg cosine theta. All right. So now you have everything. Let me put it together nicely so it looks nice. So Fg has two components, F at the F perpendicular, which is mg cosine theta, which has another name, Fn, and then Fg parallel, Fg perpendicular, Fg parallel, mg sine theta, which, so that's good. And you have Ff is of course mu k Fn, and Fn is, you already have Fn, so mu k mg cosine theta. So many of you ask for the mass. I did not give you the mass because you don't need mass. Why you don't need mass? All right, let's see why you don't need mass. I have the diagram over here. Okay, so F equal ma. All right, you study your conversation with Newton's second law, because everything is just with Newton's second law. If alien ever come to the earth and try to take everything away, you're going to tell them, take everything, except Newton's second law. We can rebuild everything using Newton's second law. Okay, so F. So this ball is moving at F parallel G, FG parallel. If there is FG parallel, then F. So then write all the things that affecting the movement or acceleration of the box. All right. So you have FG parallel, which is, and then plus FF is equal to M. Wait a minute. You probably now rolling your eyeball. Why he put plus? This one is opposite direction. You will write if you think. Okay, FG. What is it? FG, mg sine theta minus this one. I already wrote it. UK mg cosine theta, and this is m. Bingo. You don't need mass. You don't need mass. A is g sine theta minus, what is it? Mu k g cosine theta. So in the beginning I told you this acceleration is g sine theta. Why? Because I gave you general equation when there is no friction. If there is a friction, then hey, you acknowledge the friction. Okay, now find it out. G, let's use 10 sine 30 degree minus mu k 0.1 g, which is 10 cosine 30 degree. All right, so your acceleration is 4. Okay, all right, now you're going to find the velocity. How are you going to find the velocity? All right, so there is a velocity at this direction. Okay, so the velocity is Vf is equal to V. Velocity is Vf is equal to Vi plus At. All right. Initially, Vi is 0. All right. So Vf is equal to acceleration is at after 4 seconds. So let's say t is 4 seconds somewhere here. So when here after 4 seconds, all right, t is 0. So I'm going to draw it here. T is 0 and t is 4 seconds. So what is the velocity when t is 4 seconds? 4 times 4. Vf is 60%. I promise that I finish it in 5 minutes, but it's now 7 minutes. Let me finish it. You can use this tutorial. Make sure at least one student post it quickly so that I can use it sample, post it to the Google Classroom for other student to use it as a guideline. Tomorrow, once again, I want to remind you guys, resources there. Make sure you get 100. At least make me happy for one last time. See you tomorrow.